All right, you guys, 4.2, we are talking about a bunch of vocabulary words that probably look familiar to you. I believe I'm on the second page of the packet here, but we are talking about classifying triangles, so like naming them according to their angles and their sides. So first of all, we're doing angles here, okay? So make sure that you note to yourself that this chart is for angles because the one on the back page is for sides, okay? And I'm going to want you to pick one word from each page in order to name what kind of triangle it is, okay? So first of all, we have an acute triangle, and we're talking about angles here. All three of the angles are acute. So I'm going to just make up some numbers and make sure that they're all less than 90 degrees. Let's pretend like this one is 60, this one is 50, and this one is 70. And remember what we learned yesterday, that all three of these angles in a triangle always add up to 180. So you can check me, I did that in my head. All three of these equal 180. And they're all less than 90 degrees. All of them are acute, okay? So that is the way we're going to name a triangle when all three angles are acute. They don't have to be 60, 70, and 50, but as long as all three of them are less than 90, we are going to call it an acute triangle. Okay, so that is thing number one. What does a right triangle look like? So first of all, it can't all have right angles, because if all of the angles were right, that would mean they all had boxes. Then, okay, it wouldn't make a triangle, right? It would make a square. Am I correct? Okay, so all of the angles cannot be 90. That is why it says one angle is a right angle. So we have one angle right here that is a 90-degree angle. That is the right angle. And then any of the other two can be whatever. They can both be 45, one can be 50, one can be 40. There's a lot of different combinations, right? So that it adds up to 180 because it is still a triangle. But if we are going to call it an acute triangle, then all three of the angles must be less than 90. If we're going to call it a right triangle, then one of the angles must have the box in it, the 90-degree angle. Okay, and then same thing with an obtuse angle. That means one of the angles is obtuse. Look how big and giant this one is. I'm going to pretend like it is 110 degrees. Any number that is bigger than 90, that is why I picked 110 for right here. If there is one angle that is obtuse, that means we have an obtuse triangle. Okay, and the last one that we're going to pick is an equiangular. I mean, you know that equa means equal, and angular means all the angles are equal. And if you take 180 degrees, which every single triangle adds up to is always 180 degrees, right? If you divide it by 3, because all the angles are the exact same, that means that you get 60 every single time for all of those angles. Okay, so an equiangular triangle means all the angles are equal, okay? So we're going to practice real quick, and we're just going to pick one of these words from up here to describe all of these triangles down here, okay? Cool. So for number one, what I'm noticing right here is I have an obtuse angle. One of the angles is bigger than 90. It's exactly what it says right here. One angle is bigger than 90. I found it. By that definition, it means that this is obtuse. Remember, I used the word obese because the words are kind of similar. That means really big, really large. So bigger than 90. In this triangle, we don't have any numbers, but do you recognize these swoops? These swoops mean that all three of the angles are the exact same. And what does that mean when all the angles are equal? It means that it is equiangular. That is what these swoops mean. If you need to make a note to yourself that all three of them are the same, and anytime they're always the same, yes, you can assume it's 60 because 180 degrees divided by 3 equal angles is always 60. All right, what about this one? Here's one angle, here's one angle, here's one angle. So none of them are right. Let's try and figure out process of elimination. They're not equal. I don't have any right angles. I also don't have any obtuse angles. Oh, they're all less than 90. Did you catch that? That means that this one is an acute triangle. Okay, how about this next one? That, and that. All three of them, they're not equal. Again, let's try and figure out. I don't have any obtuse angles. I don't have any right angles. Oh, they're all less than 90 again. This one's acute. Okay, cool. Ooh, ding, ding, ding. I see a right angle here, which means this one is a right triangle. Okay, cool. And the last one, I see 3 equal angles, and that is written right here. All angles are equal. That means that it is an equiangular. Pretty simple, right? Let's move on to the next page because now we are talking sides. Okay, we have only on this page up here been looking at the angles. And so now we're also going to talk about what are the different sides look like. Okay, so we call a triangle that has none of the sides the same length, meaning they're all different. So let's pretend 3, 4, 5, or maybe 6, 8, 10. Any triangle that has 3 completely different side lengths, these are different numbers. I'm not talking angles on this page, I'm talking sides, okay? 3 inches long, 4 inches long, 5 inches long, those are all 3 different sides. None of them are equal. That is called scalene. It's a vocab word. Maybe you've heard isosceles before, but when this side equals this one, so like 6, 6, let's pretend like this is 4 down here. That is called an isosceles triangle when 2 of the sides are the exact same, 2 of them. The word is isosceles. And then we have equilateral. Do you remember what lat means? Lats are your sides. And equa means equal. So equal sides, that means all of the sides are different. Don't confuse that with equiangular. See the word angle right here? This is when all the angles are different. What about if all of the side lengths are the same? That's called equilateral. Okay, so all 3 sides are the same. I can make up my own example over here also. Let's pretend this is 10, this is 10, this is 7, whatever. Here, they're all the same. 3, 3, 3. I thought they were 60, Mrs. Johnson. What are you talking about? Yeah, those are the angles, you guys. Those are different. The angles are all 60 degrees. The side lengths can be whatever we want, right? This can be 100, this could be 100, this could be 100. As long as they're all 3 side lengths the same, then that is called equilateral. So let's pick a word from up here to describe these triangles down here. Notice how I don't know anything about the angles. I only have these markings for like side lengths and stuff. So for the first one, I noticed that this and this are the same. That's what those little tick marks mean. And when you have 2 sides that are the same, you call that isosceles. All right, so isos. It's okay to abbreviate it as long as I know what you're talking about, okay? Here, 13, 9, and 14, none of those are the same, which means it's called scalene. And let's see. Ooh, they're all the same on this one. 20 and 20 and 20. Okay, that looks like one of these. All 3 sides are the same. That's called equilateral. Let's do these more. Okay, I've got a tick mark, a double tick mark, and a triple tick mark. That means that this one is 1 unit long, for example. This one is 2 units long. This one is 3 units long. That means that they're all different. Okay, what's the word for when they're all different again? None of them are the same. All of them are different. Oh yeah, that word is scalene. Okay, cool. Yes, we will write this on a note card, you guys. But maybe you got the hang of it already. Okay, when all the sides are equal, this is equal, this is equal, this is equal, because of the single tick mark on all of them. It's called equilateral. Great. And I have an 8 and an 8 and a 6. So read carefully. This is 2 sides that are the same. What's it called again when you have 2 sides that are the same? Oh, isosceles. Great. Let me blast through these next examples because I have a slot for angles. That's the first page, you guys. And then I have a slot for sides. That's the second page. So let's talk about angles for a second. You can flip back and forth in your packet, but what I'm noticing about the angles, and please don't confuse the angles with the sides. Here's one of the angles, here's another angle, here's another angle, okay? I am noticing that one of them is a right angle. And when there is one right angle in your triangle, you call it a right triangle. Okay, look at the page that we circled angles at the top of. Your choices were acute, right, obtuse, or equiangular. I see a right angle, so I'm calling it right. And now let's look at the sides. That's different. Here's a side, here's a side, here's a side. And I have a single tick mark, a double, and a triple. What is it called when all 3 sides are different? That is called scalene. Okay, check your the second page. Remember, we have 2 pages of vocab words. One of them is for angles, one of them is for sides. Let's talk about number 2. I see a 70, and a 40. Okay, so all 3 of those are less than 90. I have no 90-degree angles. I have no obtuse angles, and they're not equal, so the only other choice there is acute because they're all less than 90. And let's look at our side lengths. I am noticing that I have 2 sides that are the same because they're both labeled 6. When you have 2 sides that are the same, that's called isosceles. Talk about this one. Ooh, I see all 3 angles are equal because of those swoops. That means equiangular. And I see all 3 side lengths are the same because of the single tick mark on all of them. This is called equilateral. Just remember that equiangular, the word angle is in it. And sides, those are your lats. Okay, so use the right vocab word there. Okay, be careful. How about this one? I see 3 angle measures. Let me use blue so it's consistent. 59, 59, 62. Okay, none of those are right angles. None of them are obtuse angles. They're not all the same, which means the only other choice we have is acute. Look at the first page, the very top of the box. When all 3 angles are less than 90, it's called acute. Let's talk about side lengths. I am noticing that I have 2 sides that are the same, this one and this one, because of that little tick mark right there. When you have 2 sides that are the same, flip the page. That is called isosceles. All right, I am noticing a right angle here, so that means that this one is a right triangle. And for the sides, I am seeing that we have 2 sides that are exactly the same. Again, that is called isosceles. Last one, I see an angle that is bigger than 90. That is an obtuse, an obese angle, if you will. And let's look at the side lengths, 2, 3, and 4. What is the vocab word when they're all different side lengths? None of the sides are the same. They're all different numbers. That is called scalene. Okay, great. Crushed it. Where was I? Right down here. And you guys are done. Let's crush that Delta math now, okay? Love you all. Thanks for listening.